Okay guys, welcome to the Tech Talk again. So this talk is going to be about machine learning, okay? This is long awaited and on a special request, okay? So see, the idea of this talk is not, anything practical right now. If you guys are interested enough to learn more, I can give you a practical session as well, okay? But I want you guys to understand that, understanding this theoretical part right now is very crucial. If you don't understand this part, then anything practical wouldn't make any sense. Okay. So I want to start off this session with some theoretical part. I'll show you some live examples as well, okay, of what I'm talking about exactly here. So starting off, why this talk, first of all, is because ML is often one of the most understood, topics, right? We always talk about, this, high level thing, like AI, right? Always, everywhere you hear it is like AI, right? So I want to explain a little bit about ML as well, what it is. And people often, think that it is some kind of magic going on, though it is just, data plus maths, that's it, okay? Obviously, you don't need a PhD to understand any of this. Some basic calculus, algebra, statistics, things like that. So with this also, one more thing, those who have worked with in this space like AI and ML, they understand that training a model from scratch requires a whole lot of computational power and knowledge, right? So in today's world where we have large language models like ChatGPT and others, right, Grok and so on, we always tend to move towards fine-tuning a model which is already pre-trained, right? We don't go always for training a model from scratch, because that requires a lot of cost and effort. So while it might be the future, but it certainly is, like, ML is in the heart of it. Okay, so this is very important to understand. So what we will cover in this talk is what machine learning really is, okay, and how it works behind the scenes. How exactly, when we think of training a model, what exactly happens, and what is the step that we take, right? I'll be showing you some practical demos, some examples of where it is exactly used in today's time, and how you can get started. Okay, just giving you a small example of that. So, like I said, it's not magic, right? So what it is not a mind-reading game. It's not like robots taking over and things like that, right? ML is basically like algorithmic patterns. We have to find out patterns basically in the data sets, right? And based on that, you make the predictions. That's what it is. So these are some of the most common examples that we have, in today's time where we use ML, right? It is like recommendation systems for e-commerce, fraud detection systems in mailing systems, navigation and ETA, personalized feed for social media, healthcare and healthcare predictions basically for early stage cancers, things like that. We have used ML. So see, when we think of any model, right? These are the following things that we always think of before ever writing any code or training any model, right? These things we have to take into consideration always. Okay. So first thing being is a business problem. Obviously, when you're training a model, you're targeting a specific problem to solve, right? So that is what problem you're trying to solve. That is your business problem. Data collection, right? When you train a machine learning model, you need huge amounts of data, right? It can't be you just created a simple, any database you have, with very less data, and you're training a model on that, it is basically useless at that point. So you need large amount of data, okay? Data cleaning, obviously you have to filter out what you don't need, right? Because training on unnecessary data will basically throw off your predictions of your model. So you need to filter the data, find out any biases, if the data which you have is biased towards a certain, prediction, right? Or find out, basically, if there is something that might throw out a prediction, okay? So that's what it is. Feature engineering is nothing but, let's say, I can give you an example of this. when we predict house prices, right? So features are nothing but certain factors. For example, like how big, like what is the size of the house, right? Is it furnished or non-furnished, right? Things like that. So these are features, right? Feature engineering is basically you find out major points in the data. Model training. So when you have like filtered out the data and you find out the specific features on which you want to train the model, then you do a split. Basically, you split the data into 80-20 split. Okay, 80% data you use for training the model, machine learning model, and 20 you use to actually make like evaluate the model, like if it is making the right prediction or not. Okay, so that is what is written here: model training and model evaluation. Okay, and then it goes for the deployment. Okay, so I want to talk about 3 of the major machine learning types. Okay, so there are more than this. Okay, there are not only 3, but there are more. But I want to specifically talk about only these 3 right now. Okay, just to keep it simple. So first one is supervised learning. Okay, so let's see. So in supervised learning, what exactly happens is you already know the outcome, the result of something, like some data, right? You tell the model that this data I have, right, and this is the label, right? You already name it. This data belongs to what exactly, right? So it already knows the result. And then when you give it some new data, it tries to find out, patterns in that, and then, like make a prediction like what it is exactly. So, for example, like I have given an example here. Let's say you tell the model, okay, this is a cat, right? Or this is a email. This email is a spam, right? The model studies examples and relationship between the input and the correct output. Okay. So, mental analogy I have written here. It's like a student is learning by studying a textbook with the answer key included. Okay, so you already know the answer. The common uses of this kind of ML type is image classification, whether some image is showing is of a cat or a dog, whether an email is a spam or not, credit score risk, and all these things. Okay, it works extremely well when you have lots of high quality data. Okay. Second one is unsupervised learning. Okay, so like I said, it finds like you don't. So in this case, you don't tell it what the exact output is or the result is. Okay, it will automatically find out the patterns in the data, and then based on that, it will make the predictions. Did you get the difference between these two? In the first one, you are already telling it the outcome. Okay, so it already knows what it is. Okay, but in this one, you're not telling it anything. You're just throwing data at it, and it is like finding out patterns in that data, and then based on that, it is making the predictions. Okay. So, like how it works, let's say, I will show you a demo of this, but I'm just telling you, an overview of this, how it works. Let's say you have a graph, right, on which, like a plotter, like a scatter graph. Do you guys know what it is? Where you point, how do you say? A scatter graph is basically like you have like different cluster of points, okay, on a graph, and then so in this case, what happens is it finds clumps of points on the graph, right, and it finds a center point in that cluster, and then it relates this point belongs to which center, okay, which I'll show you an example. Actually, it is hard to explain that way. So it's like walking into a party, mental analogy I'm just telling you. So it is like walking into a party and grouping people by similarities, right? For example, like these people are engineers. You created a group of engineers, you created a group of managers, and so on. So common uses for this is like topic clustering for text, customer segmentation, like what group of buyers, this user belongs to, and things like that. So reinforcement learning is basically, when you're constantly like feeding, what do you say? You're rewarding the model, or you're, punishing it based on the type of prediction that it makes. Okay. So it works on kind of like reward system. Okay. So that is what is written here. A model, or called an agent, learns by interacting with the environment, and it receives rewards and penalties. How it works? The agent takes an action, the environment responds. For example, let's say you have a robot, right? And you have told it that you have to pick up a cup, right, off a table. Then if the robot is moving in the right direction, you give it rewards, right? You give it treat that, okay, you're doing the right thing, right? In that way, it knows where to go, right? But if it is moving in an uncertain direction, then you penalize it. You reduce the reward. Then it knows that, okay, I'm doing this thing wrong. Okay, this is the simplest example I can give. So common uses, like I've given you the example of robotics, right? So that is one of the example. In games, also oftentimes when AI is used, this is the thing that is used behind the scenes. Okay, and obviously automatic cars and things like that, there also reinforcement learning is used. Okay. So what I want to do actually, I want to give you all understanding of what I'm trying to say here. Just a second, let me. Okay. Is it visible actually, the text? Okay. So before actually I show you guys the examples, right, of all the three types, I want to talk about this data processing part, because this is often the most misunderstood part in this. When we think of machine learning, right, we are basically interacting with a computer, right? So it obviously doesn't understand any of the alphabets, right? You tell it, in English we're obviously writing code, but ultimately it is converting to binary, right? So it only understands ones or zeros. So when we talk about any LLM model, right, let's say ChatGPT or anything, what happens is when these models are trained, right, then a large amount of text, right, is fed into them. Through encoding, right, we basically convert this text into vectors. Vectors are nothing but combinations and one of zeros in multi-dimensional arrays. Okay. So that's how basically it creates a relation between words, and then it understands which word belongs to where in the sentence. Okay, so that is how basically it works. So what is written here actually is, these are the steps obviously when we talk about like I said earlier also, gathering, filtering, feature engineering, encoding and embedding. I will come to that what this is, and then train, test, split. Okay. So here I have given some examples of different kinds of encodings. Now I have given only very limited examples, but there are more than this. Okay, there are different encodings for different types of data. Okay, like video, text, and things like that. So what is exactly encoding? I'm talking about encoding, right? But what it is exactly? Encoding is like, for example, I'll give you a very simple example. Here I have written the example of one hot encoding actually. This is like the very simplest possible example that I can give. See here, when you do hot and one hot encoding, right? Here I have given an example of dog and cat. So in this, if you see, I've told it that the dog is the label, right? If it is, let's say it is a word in a sentence, in a whole sentence, right? So in that, it will convert it like this. Okay, a vector basically where the first value is 1, and in the whole vector it will be only one single one. Okay, there will be only one single one value. And similar for cat, just a different combination. But like I said, it finds out relations, right? But this I want to say that in one hot encoding there is no relation between words. Okay, but in different encodings, for example, let's say BERT and GPT, these like encodings actually do create relation between words. Okay, any question or any confusion here? No? Okay. So I'm just gonna give you guys an example, okay, of all three of the machine learning types that I have explained here. Okay. So in this example, actually, I'm using scikit-learn. Okay. This you guys can also use. It is very simple to use. Okay. Obviously, better than TensorFlow. So here, what I'm doing, I'm using this thing, iris dataset. So in iris dataset, what we have, basically, what do you say? Data about a certain flower, okay, like the petal size, and the other things related to that flower, okay. So in this, what it is doing, we have already told it like what kind of flower it is, okay, depending on different features, okay. So based on those features, like the size and the color and all these things, it basically makes a prediction what kind of what kind of flower it is, okay. So here you can see that I have the data, okay. I'm loading the data set here, and then I'm splitting it basically, okay, using the train test split, and then based on that, I'm basically using a random forest classifier. So what random forest classifier is it is basically like a bunch of you can say like sub classifiers, clubbed together. And what happens is when you ask for a prediction, right, these classifiers basically vote, and whichever prediction gets the most vote, that will be your your final prediction, okay. So then I'm fitting the model and I'm making a prediction, okay, and here it is giving the accuracy rate of 1. It is like too ideal right now, but normally it is not like this. It is very, what do you say, fractional value. It is like very decimal value. I've given it a sample to predict, and here you can see that it has predicted that it is Setosa, okay. So for example, if I change it, okay, I have to change it a bit more actually. It is not going to work like that. Yeah. So see, given a different parameters, right, and now it has changed the prediction, and it says, it is like this flower now, okay. So, okay. So moving on to unsupervised learning, actually, Sumit, you had one question, right, about this. So here you will be able to actually visually see that. In the earlier example, I couldn't show any visual, representation of that, but here you can see. So in unsupervised learning, this is the kind of graph I was talking about, right? So what I have done here, actually, let me explain this part. I'm taking 3 random blobs, right? Basically points in the graph, right? And I've specified that I want 3 centers, okay? Basically grouping of 3 clusters, okay? So here in the image also you can see there is a grouping, right, between these points, okay? So in unsupervised learning, what happens is, in real data I'm talking about, so when data is scattered all over this graph, right? So what model does is actually trying to find out a center point of all these clusters in the groups, okay? And then based on that, it basically classifies, okay, this is a separate group, this is a separate group. So when you talk about a certain point, right, in to which, let's say you've given it a new data, right? So then it will predict where, what is the nearest center of that point, like to which group it belongs to. Based on that, it makes the prediction, okay? Understand what I'm saying? So same here, I'm basically using k-means clustering, okay? And I've told it that, there are 3 clusters, okay? And then I'm just fitting the model and plotting the graph here. That's pretty much it, not really too much here. So in reinforcement learning, it is like, reiterating over the same thing. So here, if you see the example, it can't be shown visually because that will be a bit difficult to show here. But if you see, in every episode, there is a reward, right, that has been given to the model, right? And as the reward increases, it tries to maximize the rewards, right? So as it makes the predictions, it tries to maximize the rewards. And if you see here, it is, in some places it is like 50, and then in some places it is dropping as it is penalized for making the wrong prediction. So here, if I talk about this code, right, I'm using the gymnasium model, And then I'm using the cart pole example. So in this example, what exactly happens is you have a cart, let's say, and in that there is a pole, right, which needs to be centered, in that cart. So the cart is moving like, forward and backward. In this case, it is 2D, so like left and right. And you have to maintain a center, maintain the pole in the center, okay, in the cart. So here what it is doing is basically if, I'm moving the cart like left and right, okay, based on how I want to be, center the pole. So that is what is happening here exactly, okay. So any questions right now? Anything? Okay. So, see, in this, what exactly happens is, when we talk about machine learning, there is, at the top level, there is AI, okay? And then machine learning is a subset of AI, okay? AI is like the broader term. Machine learning comes after that, okay? And then deep learning comes after ML. So ML is also a subset of, deep learning is a subset of ML, right? So just giving you guys an example, for example, you guys work with, TypeScript and JavaScript, right? So TypeScript is a subset of JavaScript. It is built on top of, JavaScript only. So similarly, when you talk about deep learning, it is built on top of ML only, right? So at the heart, ML is there. That's what. Thank you.